Thank you everyone for joining us for this webinar on the history of live sound part 2 presented by Andy Coules. My name is Laura Lawrence and I'm the Global Marketing Director at Harman. Just a few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a chat function where you can submit your questions and we'll answer those at the end of the presentation. This webinar is being recorded and the link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we'd like to encourage you to take a look at the different webinars in our Learning Sessions Workshop Series on pro.harman.com, as well as visiting Harman Professional University to see our many on-demand and certification courses that are available to you for free. And now I'd like to introduce you to Andy Coules, the presenter for today's webinar. Andy is a sound engineer who tours the world with a diverse array of acts in a wide range of musical genres. He also writes articles for various print magazines and created a live sound course that he's taught in London, Hong Kong, and Algeria. And an interesting little tidbit, if cancellations had not occurred due to the situation in the world right now, Andy would be in New York today mixing front of house for the band Madness. Now I'm going to pass the mic over to you, Andy.
Okay, thanks for the introduction, Laura. Just to recap what we where we got to in part 1. We covered the first 90 years of the electric sound system, from the invention of the microphone to the very first stadium show, which was the Beatles at Shea Stadium in 1965. And I was keen to point out this is a very significant event for its time because it showed that there was a big demand for large shows, but the equipment wasn't up to the task. So thankfully, there was a new generation of pioneers ready to come along and really take things to the next level. And here I've listed just a few of the sound companies that were active in the 60s and the 70s. One thing they all had in common was a knack for constructing and combining technology in new ways to build bigger and better sound systems. This is by no means an exhaustive list, but it's just a few of the ones that are memorable. I think all of them were involved in varying degrees with pushing forward what was possible with sound systems based on the technology of the time. The aspirations of bands and the expectations of audience would drive innovation on both sides of the Atlantic. And it really was quite an exciting time, I think. I'd love to tell all of their stories, but that's kind of beyond the scope of this presentation. So I'm just going to focus on two very notable pioneers, Bill Handley of Handley Sound and Charlie Watkins of Wem, both of whom have been called the fathers of sound. Bill Handley is commonly called the father of festival sound, and Charlie Watkins is the father of the British PA system, so we'll start with him. So he was a tinkerer, a sort of classic British boffin. He established his company in the 1950s building guitar amps, most notably the Dominator with its unique V-shaped cabinet. In 1958, he brought out his copycat tape delay, which was it's still in use by some people because it's got a very authentic vintage sound. Then he started experimenting with sound systems. And one thing he noticed was that he wasn't happy with the kind of general purpose loudspeakers that were available that were very stiff-coned. He thought that they were sort of better suited for the narrow bandwidth of guitars, but not really at all good for the subtleties of the human voice. So he went and sought out speakers that had much softer cones that would move much more easily, coupled with quite heavy magnets for power. The speaker he chose was a Goodman's Axiom 301, which he partnered up with a custom-built amp that he based on an RCA design, which crucially had a flatter frequency response than the average amplifier at the time. And this was what was the basis of his very first sound systems. One of the things Charlie Watkins is very well known for is being louder. His systems were generally considered louder than everyone else's. And that's because he stumbled on the power issue quite early and came up with a quite unique solution of using a slave configuration. He'd get one amplifier, connect the output of that into the input of a second amplifier, and hopefully not blow it up, but then get an increase in the amount of amplification. And he built his very first kind of big slave PA, it was called, in about 1967. He used it at the Windsor Festival, which is pictured here. It's actually the first place where Fleetwood Mac played their very debut gig. It was one of the very first 1,000-watt systems. And as you can see from this picture, if you look in the background, there are houses quite nearby, and he was actually arrested for a breach of the peace. But thankfully, the case was thrown out of court. So if we hop across the Atlantic and look at Bill Handley over in the US, He established his reputation in the 60s as a sound system designer. Most notably in 1965, he provided the sound system for Lyndon B. Johnson's inauguration and the Newport Jazz Festival, which was famously where Bob Dylan went electric and annoyed quite a lot of folk people. His systems were initially based on cinema speakers. He used the voice of the theatre made by Altec Lansing. But then he started to build his own boxes and typically combined Altec horns with JBL D130 15-inch drivers, which, if you know your history, was the speaker that established the reputation of James B. Lansing back in 1948. If you're not sure who he is, his initials are on the corner of every slide in this presentation. But what Bill Handley is most famous for, I guess, is the Woodstock Festival in 1969 in upstate New York. Now, even by the measure of the times, it was quite an ambitious plan, this festival. They wanted to have 200,000 people, and the organizers struggled to find someone capable and willing of providing such a large sound system. And then he heard about this crazy guy in Boston, and Bill Handley took up the reins of the job. He built his own custom Altec JBL boxes on 2 levels of scaffolding, which you can just see in this image on the left. But also augmented by satellite speakers to spread it throughout the crowd. All powered by Macintosh and Crown amplifiers. He managed to get up to about 10,000 watts of power, which you might think is excessive, but it actually turned out to be quite prescient, because when the fences were torn down and it was turned into a free festival, the audience swelled to about 400,000, and some people claim it was almost 500,000 people there. So it was very much a hectic event. But Handley was very proud to state that the only things that didn't fail that day, or those days over the weekend, were the sound system, the water supply, and the stage security. So as we move forward, sound systems definitely start to snowball in terms of power and capability. In 1969, Charlie Watkins debuted his festival sound system, which was one of the earliest 4-way sound systems. What he did was he used filters to split up the signal into bass, low, mid, and high frequency portions, which could then be handled individually by different amps and speakers, which were enabled to operate much more efficiently because they only had to focus on a limited part of the frequency band, and thus produced a much more high fidelity sound. Around about the same time, McCune employees Bob Carvin and John Mayer, later of Mayer Sound, built their JM3 system, which is a very powerful 3-way system, which obviously split things into bass, mid, and high frequencies. And they built it with enclosed amps and electronics in an external equipment rack with no controls on it, because they pre-configured and set it up to work perfectly. All you needed to do was connect your inputs and outputs, and you were good to go. It didn't even have a power switch. You just plugged it in, and it went. Then in about February 1970, Bob Heil of Heil Sound was called upon to provide a sound system for the Grateful Dead's concert at the 5,000 capacity Fox Theatre in St. Louis. He built 5-foot stacks with JBL 140s, the successor to the 130, 2482 compression drivers, ring tweeters, and JBL radial horns, which he could consider were crucial for the clarity in the vocal range. That system ran to about 20,000 watts. So a noticeable shift in sound systems happened around this time, because prior to this period, a lot of bands self-mixed. Notably, Peter Green of the early version of Fleetwood Mac would have a 100-watt Selmer amp on his chair next to him with 6 mic inputs and would control the vocals himself during the show. Roger Daltrey, The Who, in the early days, he had a Marshall amp with 4 speaker columns, which he would put on stage, plug his microphone in, and then just set it, much like a guitar player does. But as systems started to get bigger and more complex, the need for an external operator became apparent. So a whole generation of roadies started to be promoted to the role of sound man. And the one thing they needed was better control, because there was increasing channel counts and they needed better ways to control the systems. So if we look at what was available at the time or prior to this time, most systems would be run on something like this Altec Lansing 1567, the green one on the left. It was a 5-channel amp with a master volume and global bass and treble controls. On on the right is the Brighton Sound sort of homemade Buck Rogers mixer, as they called it, because it looked like something from a science fiction television show. That was from about 1970. And while this was fine, the small systems, the newer systems that were being built had multiple amplifiers, so there became a need to separate the controls from the amplifier so you can control the system as a whole. And of course that meant using dedicated mixers. An interesting side note is that after Woodstock, Bill Handley came up with the idea of building a mixer that was semicircular, that would be all around him. He loved the idea of being able to reach every single control easily. Sadly, he never completed that idea, but I'd love to think that that would have been the sort of template that was established. What was established was something a bit more like this. This is the WEM Audio Master from 1968. It's one of the earliest mixers I know of that was basically had the design of a vertical channel. You can see it's 5 channels, the controls are vertical, there's a main dial at the bottom for the volume, and then you've got treble and bass controls, and even a reverb. It had a spring reverb built in, much like a lot of guitar amps. They borrowed the idea from the recording studio mixers like the Red 17 that was installed in Abbey Road in about 1958 and used by the Beatles and Pink Floyd and many other people. This is actually, this picture is of a later model, the 1974 version, which has an extra monitor send on it, which is the extra small dial above the main Rebel. It only had 5 channels, which by modern standards isn't very many, but they weren't miking up everything back then. You could actually link 2 audio masters together and have a 10-channel mixer, which was quite extravagant at that time. Dinky Dawson, who did front of house for Fleetwood Mac, got 2 modified so that he could actually do stereo, because of course they're mono mixers. If you had 2 side by side, he could control the sound and make it go from side to side. And he took great joy in making the sound fly backwards and forwards, much to the amazement of the audience. So here we have another great example of a British mixer. This is the Series 1 built by Graham Blythe in 1974, which would be the first mixer to ever bear the name Soundcraft. And you can see it's pretty much nailed the design that came after. The vertical channels made it very much easier to build them in different frame sizes. You could come up with a basic template for your desk and then alter the amount of channels depending on the need. This one here is the 12-channel version. It was also available in the 16-channel version, both of which featured 4 outputs, because this is of course a stereo mixer. 2 of those were stereo, one was a pre-fade send and the other was post-fade for obviously monitors and effects. And it was perfect for live use because, as you can see, it was built into a flight case, so it was very popular with live sound engineers. An interesting point is if you look closely at the EQ section, which is the grey dials, this one's got 4 fixed filters, so you just were able to boost at 4 fixed frequencies or cut. George Massenburg hadn't quite developed his parametric EQ at this time, but 4 years later they launched the 1S in 1978, which established this sort of classic 4-band EQ design, which has a top and bottom shelves complemented by 2 parametrics in the middle. So the next kind of issue that our brave pioneers had to confront was the mix position. It was very common to lose signal over long cable runs, and interference was quite a major issue. So the mixer was always positioned close to the speakers and close to the amplifiers, which often meant at the side of the stage, much like in this picture. Bill Handley, for one, was never happy with this arrangement. He always felt that the person mixing had to be out the front where the audience were so he could mix it for them. But it wasn't a common practice. But he took up the challenge when he was asked to help build the system for the Fillmore East, the famous venue in New York's Lower East Side. He got together with John Chester, the technical manager at the time, and built a large box of transformers at the side of the stage, and then another box out front, which enabled him to run high impedance mic signals down a long balanced line with no interference and minimal signal loss. So, of course, front of house mixing was born. And here is a picture of the Fillmore East with when the Doors played there in 1968. They didn't quite get front and center with their front of house. It was actually off at the side, up near the balcony, but it was certainly a step in the right direction. And it's something we very much take for granted nowadays, but it took a while for people to take up this idea. because of the problems involved. Dinky Dawson, who was on tour with Fleetwood Mac, visited the Fillmore East in 1968, and he'd never seen anyone mix out front, and to him it was a revolution. He couldn't believe. The only problem was that taking large boxes of transformers on tour was difficult, not really practical at the time, but luckily certain mic manufacturers started to include transformers within their microphones, which enabled people to actually build multi-cores and start mixing from front of house. Dinky Dawson again observed this simple innovation and said that it changed live entertainment forever. So next. So now that we have much bigger and louder sound systems, the next challenge that really arises is that musicians start struggling to hear themselves. The sound systems, of course, is pointing away from them into the room. Any sound they hear is delayed because the speed of sound is really quite slow. Your average kind of concert hall take a couple of seconds for the sound to get to the back and back to the stage. So it would make it very difficult for people to play together and sing in tune. However, the idea of foldback was not unheard of. When I say foldback, I mean the idea of folding back the sound onto the stage for the musicians to hear themselves. As early as 1961, Harry McCune Sr. Installed extra speakers to point to the band for a concert for Judy Garland when she played at the Civic Center in San Francisco. Interesting side note, that's also the place where the first ever live amplified concert happened in 1915, if you remember from part 1. The problem with monitors at that time was that it was quite difficult to implement because not all of the mixers had the necessary outputs. And the idea of folding back the main mix was problematic in terms of feedback if you couldn't control it independently of what was going out to the audience. Of course, Bill Handley had an interesting approach to this. He was working with Buffalo Springfield, and he noticed that, this is around about 1967-68, he noticed that they were still hiring his PA system when they weren't on tour. So he was curious about this, so he paid them a visit, and he noticed that they basically got the sound system, turned it all around, and they were using it as a monitor system. And that was, for the first time, it dawned on him that he'd been so focused on the audience and giving them a good sound that he'd never even thought of the needs of the band. So he started mounting speakers on the floor at 45-degree angle, the beveled edge, so that they pointed up, and he called these Footlight speakers. As you can see in the photo, it's obviously what we've now come to know as the wedge. And as more mixers started to include extra outputs, monitors became much more common, and musicians found them pretty vital to their performance. And of course, then they developed monitor desks and a much more complex system where it's independent from the front of house. But it's interesting to note that monitor wedges weren't always welcome. Mike Klaczynski, who was working with Pink Floyd, said that when he first saw wedges, he noticed they spread like a virus. And he found himself battling the secondary sound system, which was essentially pointing backwards from the stage and struggling for control of the mix. It's something we've had to deal with, I guess, for many years now. But now we've got kind of the main parts all in place of the sort of modern PA system, and this is a very simple diagram to show you that. As we enter the 1970s, the template is established, pretty much a template that persists to this day. You've got a ground stacked PA system, which is either 3- or 4-way. You've got separate monitors on stage, controlled separately from the front of house. And of course, you've got your front of house where the sound is mixed from. There were many variations on this, often hanging and suspended systems, but as mixers and speakers and venues got bigger, the configuration pretty much stayed consistent. It just got scaled up or down to suit the environment in which it was being used. This didn't stop bands from getting involved in quite a childish kind of arms race. Big bands like The Who, Pink Floyd, Cream, and Led Zeppelin were touring in the 70s, and they'd go to people like Charlie Watkins, and he said that The Who came to him, he gave them a 1,000-watt system, and then Pink Floyd heard about it, and they said, oh, we want a 2,000-watt system. They had to be louder than the other bands. It was quite a funny period. But as we move forward in the decades, this kind of excessive volume, I think, contributed in some small way to the kind of next big step forward for live sound, which is in-ear monitoring, also known as IEMs. People often assume it's quite a recent development, but I've found evidence of devices going back to about the 1970s, which were typically wired. I'm much more interested in the wireless IEMs because they have a much more direct impact on live sound and performance, which I'll explain in a moment. When it first started, I think it was in about the mid-1980s, Chris Lindup, who was touring with Jeff Beck, was getting very frustrated with the kind of loud stage volumes from the monitors. He would turn the PA off at the front and the level didn't really go down by a noticeable amount. So he started tinkering with FM transmitters and little pocket receivers. He coupled these up with Sony Walkman earbuds and kind of had his first prototype of a wireless IEM system. It was used initially by Stevie Wonder when he played Wembley Stadium in London, and he loved it. It also had the added bonus that he could have a minder on the side of stage with a microphone talking to him so that he could guide him across stage, because obviously, I'm sure you're aware, Stevie Wonder was blind. And this also shows us that in-ears are great for giving information to musicians that you don't want the audience to hear. So nowadays, it's quite common for musicians to have click tracks or cues or count-ins on their in their ears, particularly obviously when people are using backing tracks, which is something that just wasn't possible when we had wedges. So Chris teamed up with Martin Noah and formed a company called Garwood Communications and produced one of the first commercial wireless IM systems, the radio station, in 1987. And a lot of bands like U2 and a lot of the big acts at the time started using these. And it's absolutely no coincidence that this coincides with the era of massive kind of arena and stadium shows, because it really freed up the musicians to move around. Other obvious advantages, of course, were there's less feedback on stage because you're not battling against monitors, making the stage much quieter. So that's IEMs, the impact they've had. The next kind of major milestone comes as a result of advances in computer technology for samplers and digital audio. And of course, I'm talking about digital consoles. This is a picture of one of the very first ever commercially available digital mixers. It's the Yamaha DMP-7, which was available in 1987. It was designed as a recallable mixer for keyboard players. You can imagine those keyboard players who had loads of keyboards. They needed a way of mixing them and maybe being able to change the settings during the show automatically. But I think live sound engineers had a look at this and thought, oh, this could be useful. So they started using them, and then other models were developed specifically for live sound. These early desks were very expensive. I think the uptake was very slow. It's a difficult thing because they involved a significant amount of research and development for the manufacturers and quite a high degree of risk. Because if you think about it, you've got the opportunity here to reimagine the control surface of a mixing desk, because we were harnessed to this channel layout that was so popular in the 70s and beyond. So there was, like I say, a significant amount of risk and cost in trying to develop digital mixers. It's also not unfair to say that the early ones didn't sound great. It certainly sparked into fire the kind of raging blaze that is the analog versus digital debate, which get two sound engineers together and sooner or later they'll get onto that subject. Thankfully, things improved, the technology got better, and the desks improved. So the dominance of digital desks was inevitable. This is the Soundcraft BI6. As processors become much more powerful, we get the ability now to put all of the processing into one box. All of the outboard, all of the extra gear, gates, compressors, reverbs, effects units could now all be in one place, which makes things much easier to transport, much easier to set up. But there is very much one key feature which was a game changer for sound engineers, and that is, of course, total recall. Again, this is something we take for granted now, but if we remember back to the distant past of the analog days, when you turned up at a venue, you would pretty much build your mix from scratch every day. Unless, of course, you were one of the big acts who were able to carry their own desk, but only a few people could afford to do that because desks were pretty big and shipping costs not small. But thankfully, when digital came in, all you have to do is press load, and your yesterday's show settings are all right there in front of you, ready to go. So you could actually do a lot more processing. If you combine this with prodigious channel counts, advanced routing and busing options, and effects, it's easy to see why digital consoles have changed how we mix forever. live shows can be much more like the studio recordings and much more consistent from night to night. So it really has had a massive impact on live sound. And whilst at first the technology was only really available to the top flight acts, the technology has become more and more affordable and has started to filter down to all levels of the industry and has gradually taken over. I can remember as little as 10 years ago, in 2010, I was on a tour where I was using house desks every day, and pretty much half and half were analog and digital, so it was a real hodgepodge of what I was getting every day. Now I'm actually struggling to remember the last time I used an analog desk. It was at least 2 or 3 years ago, so it just shows you how in a relatively short period they've just taken over everything and changed the way we do things. So you might think that we're pretty much up to date now, and this is the end of our story, but there is one last innovation that we need to cover. I think some of you might be able to guess what I'm talking about, but if we look at ground stack systems, the big PAs of the past, they were often referred to as point source systems, which is misleading because a point source is something that radiates sound equally in all directions, but these didn't do that. They were not equal at all frequencies. And just to illustrate that, I've got a CLF file to look at. If you've not come across CLF files before, it's a common loudspeaker format, which allows manufacturers to share data on their speakers with people so that they can do computer modeling. It's an open source format, and it's quite good for that. Here I've got a simple three-way speaker enclosure, which is much like a mini sort of sound system. And you'll see the legend up here. Obviously, if it's loud, it's red. If it's quiet, it's blue, so all the spectrum in between. So what we can see is that at 250 hertz, your average sound system is very similar to a point source. It's a little bit louder at the front and the back, but the sound is pretty much going out equally in all directions. As we get up to 500 hertz and 1000 hertz, we start to see it going out more at the front, at the sides, and at the top, but very much less at the back. And as we go up through 2000 hertz, 4000, and 8K, it becomes very much more directional. Your sound is only going out the front of the speaker. This is the kind of behavior that anyone who's stood next to a sound system has observed this. We all know that it's much more full out front, and as you get round the back, it gets duller and more bassy. And what this means is that those sound systems typically tended to spray a lot of low frequency and low mid energy all around the venue in backwards and sideways on the floors and the sidewalls, which of course would cause delayed reflections. And if the room wasn't particularly dry, and few are, you risked a very messy and muddy sound. But this is another characteristic of point sources is the way in which the energy dissipates. Because it does go technically in all directions at once, you've got this expanding sphere of sound. It conforms to the inverse square law, which tells us that the sound level will drop to 25% of its level for each doubling of the distance. Again, this is easily observed because we all know that sound is louder at the front, it's quieter at the back, and it's kind of just right in the middle. It's what we often call porridge sound, sort of based on the story of Goldilocks and the Three Bears. And seeking a solution to these issues is what drove the next great advance in sound. And as I said, I think some of you are probably ahead of me on this, but what I'm talking about, of course, is the line array. And here's a lovely picture of a JBL Vertec being used at the Rock in Rio festival, which was being held in Lisbon in Portugal. And these line arrays, I think even to non-sound people, they're very familiar. That J-curve has pretty much become ubiquitous, particularly at outdoor shows and festivals. The modern era of the line array was kicked off in 1994 by Christian Heil with his VDOS system. And the reason I say modern is because the principles of line arrays were actually established in a paper by Harry Olsen as far back as 1957, where he talks about the benefits of column speakers having a wide horizontal and a narrow vertical dispersal. And these principles were actually used in early systems in the 1960s, such as the Shaw Vocal Master and the Marshall columns. But what Heil did was to refine the science of it, to take advantage of the constructive interference from having very carefully aligned adjacent speakers reinforcing each other and pushing the sound further. And one of the benefits of this was that there was much less drop-off in level, which means you increase that kind of just right area in the middle to encompass much more people. And it also enabled, to some degrees, a more even frequency response throughout the venue, which resulted in a lot less spray, of course, with less going up and down and more going straight ahead. And the line array is, of course, very much a product of the computer age. Here I've got a screenshot from JBL's line array calculator, because it's very much about precision modeling and precision deployment to get the right results. So it's, yes, it's of its time. And while line arrays are very much a product of sound system evolution, I always like to make the point that they're not a universal solution. Some situations and some environments, a sort of ground stack would work much better. And some people prefer ground stacks to line arrays. It's very similar to the analog versus digital debate, but that'll rage on for years, I'm sure. So that has brought us pretty much bang up to date. And I hope I've been able to illustrate why I love working in live sound. It's an industry that's constantly evolving with new technology and innovations. And I, for one, am certainly excited to see what's going to happen next. So before I leave you, I'm going to share with you my bibliography and some suggestions for further reading. These are all books that I found really useful in researching this subject. William F. Jensen's book on the value of the Vox is all about Magnavox and their advances in the early 20th century. John Kane's brilliant book on Handley sound is incredibly detailed on his whole history. Dinky Dawson's book is quite funny. Talk about life on the road and the adventures he got up to in his career. And Mark Cunningham has also written a great book on the Pink Floyd sound system, as well as the concert industry in the 90s. And of course, I should also name check Harry Olsen, because his acoustical engineering paper from 1957 is really a good read if you're interested in the science of line arrays. So that's about me done. Now, I'll leave that on the screen for you if you want to take note of that or take a shot of it. And I'll invite any questions if anyone has any.
Thanks, Andy. No questions have come in, so just a reminder, if you do have any questions for Andy, you can put them into the chat box right now. And while we're waiting for that, I have a few links that I wanted to send out to all of you. The first link is a link to our Harman Professional University, so you're able to access our thousands of hours of curriculum, content, and certifications. So that's going to give you an overview of information and get you to the registration page to sign up. And then the second link I'm going to send you is to our playlist on YouTube of all of our webinar recorded sessions. And the third link is to our full calendar of upcoming webinars. So let me send those off to you in the chat box. There you go. And it looks like a question did just pop up. Okay. Any thoughts on the future of live sound immersive and personalized peaks system being used on Elton John's tour?
Well, I think some of the advances that are being made at the moment are to do with much more tightly controlled sound systems, and there's quite a lot of exciting stuff going on with 3D sound systems, which I'm quite interested in. I hope that becomes more common. I'm not familiar with the Elton John peak system, so I can't really comment on that.
Okay, we do have another question. When Bill Handley set up that first festival system and added the satellite stacks, did he use any sort of delay to feed them?
As far as I know, he didn't. They did it kind of just connected directly so that there would be no delays, but I think they did them at such a distance that the sound from stage wasn't a major issue in terms of fusion with the delay times, the arrival time, sorry, the sound.
Okay. Just give it another minute to see if anything else comes in. And just a reminder, if you missed part one of this session, that recording will be available on that YouTube playlist that I just sent to you in the chat box. Okay, here's a question. You mentioned the breakthrough for front of house mixing when transformers made it onto the side of the stage in order to balance the high impedance mic signal. Was the DI box introduced around the same time or much after?
I'm not sure exactly when the DI box was brought in, but it probably would be about the same time because it essentially does the same function as those transformers. Those were, of course, for the mics at the time were predominantly high impedance, so that was part of the issue with signal loss and interference. When they put the transformers inside them, they all became low impedance, so that made it much easier to have longer cable runs and less interference. I hope that answers your question.
Okay. All right, it looks like that's all that's come in right now for questions. So Andy, thank you so much for doing part 1 and part 2 of the history of live sound. It was a great session. As a reminder, all of these were recorded. You can find them out on the YouTube channel. And if you want to see the full calendar of our upcoming sessions, just go out to pro.harman.com and you can register for anything that's upcoming in May and in June. So thank you everyone for attending and have a great weekend.
Thanks. Bye.